Hi students, now this second case under the effect of dielectric in a capacitor is when the battery remains connected to the capacitor. So in both the pictures you can see the battery is connected. Now as usual, when the dielectric was not introduced, what will be the capacitance of the capacitor? The capacitance is denoted by the symbol C0, and this is equal to Q0 divided by V0. So this is the first equation. Now without removing the battery, if I introduce a dielectric between the plates of the capacitor, now also the potential difference V0 will remain the same. So the new potential difference after introducing the dielectric, the new potential difference between the plates is V0. So it V0 is a constant. As a result, what will happen to the new electric field then? The new electric field, okay, the new electric field is now this E is equal to V0 divided by D, that is equal to E0. So electric field is also what? A constant. So even after introducing the dielectric, there is no change in the potential difference under the electric field. But what will happen to the charges? Now the charges will increase. This was explained by Michael Faraday in a separate experiment. So the new charge in the capacitor, the new charge appearing on the plates of the capacitor will be Q is equal to epsilon R times Q naught. So this is based on Faraday's experiment. Okay, he has experimentally proved. So when a dielectric is introduced in the presence of the battery, potential difference in electric field does not change, but the charges will change. So the new charge Q is equal to epsilon R times Q naught. So this is equation 2. Therefore, what is the new capacitance then now? The new capacitance is denoted by the symbol C. So this new capacitance is equal to the new charge divided by the old original potential difference, C equal to Q by V. But instead of this, the new charge which is stored in the plates, we have to substitute. So this Q is equal to what? Epsilon R times Q naught. So this is equal to epsilon R times Q naught divided by V naught. But Q naught divided by V naught is equal to what? As per the equation 1, that is equal to the original capacitance C naught. Therefore, the new capacitance is equal to epsilon R times C naught. So this is equation 3. So this C naught is that of an air capacitor and C is the dielectric capacitor. So I can substitute this is equal to epsilon R into this is epsilon naught into A divided by D, and the product of epsilon R into epsilon naught is equal to what? Epsilon. So epsilon into A divided by D. Okay, this is the new capacitance after the introduction of the dielectric. So the dielectric is occupying the entire space between the two plates, and then only this equation is permitted. Okay students? Okay, now what will be the new energy, new electrostatic energy, okay? It is denoted by the symbol U. So this new electrostatic energy, before that let us say the original electrostatic energy we have studied half CV square, is it not? Like that now the new electrostatic energy is equal to half into C into V naught square. Here we are not using the expression half Q square by C, is it not? Why we are not using the term U equal to half Q square by C? Because Q also is a variable, C also is a variable. Both the variables if you use means then the energy will become constant. In the first case, in the previous case when the battery was removed, we used half Q square by C because the charge was remaining constant, only C was a variable. Like that, my dear students, now I am using the symbol half CV square or half into C into V naught square, because the potential difference V is nothing but a constant. So I am using V naught. So V naught is a constant, only C is a variable. Out of these two factors, one should be variable. That is why I am using this term. So this is equal to half into, instead of C, I am going to use epsilon R into C naught. So this is epsilon R into C naught into V naught square. So this is equal to epsilon R times half into C naught into V naught square. Okay. So here in this, before the dielectric was introduced, let us take that the energy is equal to half into C naught into V naught square. Okay. So now it becomes epsilon R times half C naught V naught square. Therefore, what is U is equal to epsilon R times U naught. That means epsilon R times the energy increases, because epsilon R is always greater than 1, is it not? So I am going to summarize all these equations like before. Okay, like before I am going to summarize all these. So whenever this dielectric is introduced and the battery is also present, then you can see that the charge Q, okay, the charge Q increases, epsilon R times it increases, and the electric field remains constant, and the potential difference remains constant. Okay, then the capacitance here also increases epsilon R times, and the energy also increases here. So this is the summary of the second case. Okay students, have you all understood? Okay, fine.